2-6b, rational functions. Now in this video, we're going to talk about slant asymptotes, whereas in the last one we talked about vertical and horizontal. Now, slant asymptotes, just like horizontal and vertical asymptotes, are represented by dotted lines, but now, since they're slanted, these dotted lines will go at an angle. For instance, we have a dotted line this way. Our function might look something like this. So it would approach our vertical asymptote. Now, the key thing here is graphs can cross over it if they want, kind of like a horizontal asymptote. Right? They can cross over it if they want, but they don't have to. Now, to find a slant asymptote, what you want to do is you want to check your rational function to see if your degree of the top is exactly one higher than the degree of the bottom. So like in this function, x squared minus 4 over x plus 1, the degree of the top is 2, the degree of the bottom is 1. So since 2 is exactly 1 higher, this one is okay, and it will have a slant asymptote. An SA, slant asymptote, abbreviated SA. Now this one, x cubed minus 4, this has a degree of 3 in the top and a degree of 1 in the bottom. So this one will have no slant asymptote. All right. Now, to find the equation for the slant asymptote, so we know exactly where and how to draw this line, what you're going to do is you're going to use synthetic division, which I know you all know and love, to divide the fraction, and you're going to toss the remainder. The remainder is not going to matter one bit. All right, all we're worried about is the polynomial that you get, not the remainder. Let me show you what I mean here. Let's find the slant asymptote for x squared minus 4 over x plus 1. All right, your x plus 1, remember we're going to have to change this to a minus 1. That's going to go outside. Remember, your bottom polynomial will always be the number on the outside. And then when you set up your synthetic division, you're always going to take the top and put it inside for your synthetic division. So this is going to be 1. We have no x term, and then negative 4. So now we just simply synthetically divide, and our remainder here, we're not really going to worry about. So bring down to 1, so that's 1. Negative 1 times 1 is negative 1. 0 minus 1 is still negative 1. 1, negative 3. But we're not going to worry about this because we don't use the remainder. All right, don't use the remainder for slant asymptotes. All right, you will not need it. So now, here we have our 1 and negative 1. So this is going to, since we started with the second, this is going to be a first. So this is going to be x minus 1. Well, the equation for a slant asymptote is simply y equals x minus 1. And we found our slant asymptote. That right there is the equation for our slant asymptote. All right, pretty simple. Main thing is to make sure that the degree of your numerator is exactly 1 higher than the degree of the denominator. That is what is important. All right, let's do a you try. Find the slant asymptote for x squared plus 3x minus 5 all divided by x minus 4. First, figure out if it has one, and if it does, find it. So go ahead and pause the video for a moment, figure this out, and come back. All right, so first of all, let's check. Let's make sure our numerator is exactly one higher. 2, 1, so it's exactly one higher. So now we're going to do our synthetic division. Since this is x minus 4, we're going to have a positive 4 out front. And then we're going to have 1, 3, negative 5. And remember, the remainder is going to be under this last one, and we're not going to care. So bring down to 1. 4 times 1 is 4. Bring down to 3, 7. Doesn't really matter what this is. So this is going to be x plus 7, because we started with the second, so we end up with the first. So y equals x plus 7 is our slant asymptote. Alright, pretty simple. This is probably going to be the shortest video ever, because I'm done. That's all I'm going to show you. You know synthetic division, so there's no need for me to keep having y'all do synthetic division problems. I mean, and with this, as long as this is 1 degree higher than this is, you just do your synthetic division and boom, you're done. So I'm going to shut up now.